Hi there, and welcome to this lesson. In this lesson, we'll be learning systems of equations, and basically we'll be learning to solve systems of equations by method of substitution. Now, as the lesson progresses, if you have any issues at all, anything comes up as unclear, please feel free to get in touch, okay? We would be more than happy to help. Okay, let's jump right into the lesson. So systems of equations, what are systems of equations exactly? Now, systems of equations are collections of two or more equations with the same set of unknowns. Okay, for example, we have x plus y equals 5 and 3x minus y equals 3. Now, this is a set of two equations, okay, and basically we have, if you notice, we have two variables in this case. We have two unknowns, x and y, and basically we're looking to solve for values for x and y that would not only satisfy the first equation but would also satisfy the second equation, i.e. values for x and y that would work for x plus y equals 5 and would also work for 3x minus y equals 3. Now, if you consider the first equation in itself, okay, on its own, basically you would end up with an infinite number of results. Okay, so basically numbers, values for x and y that will satisfy x plus y equals 5. Basically you have x equals 1, y equals 4. You have x equals 2. When x equals 2, y would be 3. You have x equals 3, y equals 2, x equals 4, y equals 1. You can actually keep doing this, okay? But then, and if you do the same, basically, if you do the same for 3x minus y equals 3, you'd have x equals 1, y equals 0, x equals 2, y equals 3, x equals 3, y equals 6, x equals 4, y equals 9, x equals 5 would give you another y value. And basically, like I said, you can keep this going. You can continue doing this. Now, as I said earlier, we're looking for values for x and y that will not only satisfy the first equation, but will satisfy the second equation. So in a way, the first equation, the idea of having the values satisfy both equations constrains your results. Okay, so basically, as opposed to having an infinite number of results, there's only one point, or only one point where your values will satisfy the first equation as well as the second equation. And if you look through, you notice that we have that point at x equals 2, y equals 3. Okay, and basically that's the idea we're going to be discussing in this lesson. And what we have is we have two equations, and we're looking for two equations with two unknowns, and we're looking for values for x and y that will satisfy the first equation as well as the second one. Now, something we need to know, okay, for a system of equations to be solvable, the number of equations must equal the number of unknowns. For example, you could have an equation like this with 3 unknowns. You can have 4 unknowns, you can have 5 unknowns, if you can have 5 unknowns even. But then basically it just has to follow one law. If you have 2 unknowns, you must have 2 equations. If you have 3 unknowns, you must have 3 equations. Now, in a case like this, where you have 3 unknowns and you have just 2 equations, this is not solvable. You can't solve for these values. Okay, so anytime you see a set system of equations, for the system of equations to be solvable, you need to have equal number of unknowns and equations. So there are two methods for solving systems of equations, okay? And basically, we have the first one, substitution, and the second, elimination, all right? Now, when you're faced with a system of equations, you would not always have to outline all the possible results and then find the joining point as we did there. You could solve them, basically we solve them using either the substitution or elimination method. And yeah, we just go ahead and do that now. So in this lesson we'll be talking about the substitution method, okay? And the substitution method, what's the substitution method about? Now, consider the set of simultaneous equations, okay, something to know, something to take note of. When you have a system of equations containing two equations, we call them simultaneous equations. So consider the set of simultaneous equations x plus y equals 5 and 3x minus y equals 3. Okay, so the same set of equations we had previously, and now we're going to attempt to solve this using the substitution method. Now, how do we solve using the substitution method? We're going to label our equations. The first equation is equation 1 and the second is equation 2. Now, the first thing we're going to do is we're going to select an equation and a variable. Okay, so we have equation 1 and equation 2, and we have x and y. So we're going to select an equation. Okay, so I've decided to go with equation 1. Okay, you could go with equation 2, it's up to you, but I've decided to go with equation 1, and I'm going to select a variable, either x or y. I think I'm going to work with x. Okay, so that's the first step. Now, the next step is to make the selected variable the subject of the equation. Okay, so basically if you go back to what we did when we're doing subject of formula, we have x plus y equals 5. We're looking to make x the subject of this equation. So x plus y equals 5, x equals 5 minus y. Okay, basically just get x on the left and everything else on the right. We move y over to the right and it becomes minus y. We have x equals 5 minus y. Okay, so now here's why it's called the substitution method. We're going to substitute the result into the other equation. Okay, so basically our other equation is 3x minus y equals 3. Okay, and then basically we found that x equals 5 minus y. Now what I'm going to do is I'm going to put x equals 5 minus y. I'm going to put 5 minus y for x in this equation. So anywhere I see x, I'm going to put 5 minus y. So we have 3x minus y equals 3. This becomes 3, 5 minus y equals 3. Let's do that again. Basically, we have 3x minus y equals 3, and we found that x equals 5 minus y from the previous step. Okay, now we're going to put 5 minus y for x in the other equation, in this other equation, i.e. 3x minus y equals 3, and really what we have is 3, 5 minus y equals 3. Okay, and then we just go ahead and simplify this. Basically, we expand that bracket. We have 15 minus 3y minus y equals 3, and then we move things around to bring the like terms together, and you notice we now have a simple linear equation. We don't have two unknowns in our equation anymore. We now have just one, okay, just y, and basically we can now go ahead and solve for y, and what happens is we end up with y equals 3. Simple. Now once you've gotten that's our first result, y equals 3. So we know y now, and we're looking to solve for x. Now to get x, we just need to put our value for y into either of the equations. So basically you could put it into equation 1, you could put it into equation 2. Okay, and basically I'm going to go with equation 1, and I'm going to go with equation 1. I think for this stage, for this step, the best equation to go with is the result from step 3. Okay, it's the simplest one to work with, because basically you already have x equals 5 minus y, and I have that y equals 3, i.e. x equals 5 minus 3, and what I have in the end is x equals 2. And that is how you solve a set of simultaneous equations using the substitution method. Very simple. First thing, select an equation and a variable, then you make the selected variable the subject of the equation, and then you substitute the result into the other equation. Okay, so into the other equation, and then finally you get your first answer for your first unknown, and then you substitute the value of your unknown into any of the equations. It will work in any of the equations, but like I said, the best equation to go with is the equation you got in step 2, where you made your selected variable the subject of the equation. Is the simplest to work with. And then yeah, let's do a few examples. An example 1. Example 1 says solve the following set of simultaneous equations using the substitution method. Now we have x minus y equals 1 and 4x plus y equals 9. Now Like I said, first thing we want to do, we're going to pick an equation, and I'm going with equation 1, okay? And I'm going to pick a variable. I'm going with x, all right? And basically, next thing we want to do is we want to make x the subject of formula in that equation, subject of that equation. And basically, we have x minus y equals 1, x equals 1 plus y. Simple. Now that we have that x equals 1 plus y, we're going to substitute our result x equals 1 plus y into for x in the other equation. So our other equation is 4x plus y equals 9, and basically I'm going to put x equals 1 plus y for x. I'm going to put 1 plus y for x in this equation. So basically we have 4x plus y equals 9. This becomes 1 plus y equals 9. And then we simplify that out. It just becomes a very simple linear equation with one variable, okay? And then we just go ahead and we end up with y equals 1. Now that we've gotten our first unknown, we're looking now to solve for x, okay? We have y now, we're looking to solve for x. And basically to solve for x, we just draw out any of the equations, but like I said, the best equation to go with is the equation you got from step 2. So x equals 1 plus y, and basically we found that y equals 1, and we just go ahead and we arrive at x equals 2. Very simple. If you choose to put your answer, basically y equals 1, into your second equation there, basically you'd end up with, you have 4x plus y equals 9. You're looking to put y equals 1 into that equation to solve for x. Basically you'd have that 4x plus 1 equals 9, i.e. 4x equals 9 minus 1. And then you have 4x equals 8, and you would still end up with x equals 2. Basically just trying to let you know that you can actually put that y value into any of the equations. It could be equation 1, equation 2, or the rearranged equation you got from step 2. But like I said, the best and easiest one to work with, so you avoid any errors, particularly if you're in an exam, is to put it into the result you got from step 2. So let's do, I think we have one more example, and then basically this one says solve the following set of simultaneous equations using the substitution method. And we have 2x minus 5y equals minus 6, and we have minus x plus 3y equals 4. Very simple. We're going to select an equation and select a variable. So I'm going to tell you why I keep selecting I've selected x a number of times. I'm going to tell you why I'm selecting the variables I've been selecting. Now, it's easier to work with variables that don't have coefficients, okay? When they have coefficients, you can work with variables. For example, I could use I could be selecting a variable, an equation in a variable. I could pick equation 1 and make use of y, i.e. I'll be working with minus 5y. But then coefficients often complicate things. So basically when you're looking to select an equation in the variable, the best variable to work with is a variable without a coefficient. And basically I'm going to just pick x again because x is the easiest variable to work with. And now making x the subject of formula, I just have x equals 3y minus 4, and then putting that into our other equation, I basically have 3y minus 4 minus 5y equals minus 6, and I'm going to simplify that and I end up with y equals 2. And then I put that back into our other equation, okay, and basically x equals 3y minus 4, and we found that y equals 2. And I have x equals 3 multiplying 2 minus 4, x equals 6 minus 4, and you'd find that x equals 2. So the solutions for this set of simultaneous equation is x equals 2 and y equals 2. Very simple principle. Okay, you just need to take note of the 1, 2, 3, 4 steps. Okay, first select an equation in the variable. Second, make the selected variable subject of the equation. Third, substitute your answer, substitute your result into the other equation. And fifth, substitute your new result, okay, your the unknown, the found unknown, into any other equation to find the other unknown. And once you've done that, yeah, you're pretty much good to go. One thing you should know is that it's often wise to check your answers when you arrived at one. Okay, so basically when you're solving simultaneous equations, put your answers back into the equations to be sure they're correct. For example, we have y equals 2, x equals 2. If we plug that back into the equation, 2x minus 5y, we should have 2x with x equals 2 will be 4, and minus 5y with y as 2 would give us 10, and what we have is 4 minus 10 equals minus 6. Yeah, that's correct. And basically we have minus x plus 3y. Minus x would be minus 2, and plus 3y would be plus 6. Minus x plus 6 will give us 4. So that tells us that our answers are correct. And yeah, bye for now.